All right, this is Unit 7, Day 2 notes, talking about permutations, which is basically how many possibilities can something happen. And the biggest thing, and tomorrow we're going to talk about, there's permutations and then there's combinations. And we're going to talk about the difference on a different day. But permutations is where ordering, is basically the ordering of a certain amount of objects. The biggest thing about permutations is that order matters. It's so important to know that that's what's special about a permutation is order always matters. So like for example, if you're like have 5 people and you want to know who's going to be president, vice president, or secretary. Order matters because if I say that Alex is president and Jalil is VP, there's a difference between that and saying that Jalil is president and Alex is VP. There's a difference between those two. So that's why permutations is super important. That's also the same thing as saying I'm going to say that I want to seat Jalil and Christian and then Hunter together. But that's different from saying I'm going to put Hunter, Christian, and Jalil because it's in a different order, okay? Order matters. That's why we include all of those. So like, for example, Jack, Bob, and Alex is a different permutation from Alex, Jack, and Bob because they're the same people, but they're in different order. So that's why it matters. So how many permutations can we make if we have those 3 students sitting in the same row? So, for example, you could have Jack, Bob, and Alice, but then you could also have Jack, Alice, and then Bob, okay? Or you can switch up who's going to go first. You could all of a sudden put Alice first, and then have Jack and then Bob, or switch up Jack and Bob and put Alice, Bob, and Jack. Or you can put Bob first, and then Alice, and then Jack, or Bob, Jack, and then Alice. Okay, there's all those different options. That's 1, 2, 3, 4, 5, 6 different permutations or 6 different possibilities that could happen. And with the fundamental counting principle, that's when you're adding or finding how many different options you have. Okay, but here we're going to do what's called a factorial, where we have 3 different people and we do what's called a factorial. It's 3 exclamation point. And what factorial means is I'm going to take 3 and multiply by every number below it. 3, 2, and then 1. You just stop at 1. Okay? Which is equal to 6, because 3 times 2 is 6, times 1 is again 6. So that's 6 different possibilities. And so that's what's going to help us with permutations, with finding how many different possibilities there are. Okay, so like for example, A, B, C, D, that's 4 different letters. So I want to do 4 times 3 times 2 times 1. Because the reason why we do that, and it says noticing ordering any one pattern can be found by using the pattern n times n minus 1 times n minus 2. Because once I have, for example, those 3 people, well, once I take away Jack, then I still have Bob and Alice, which means I only have 2 people left. And once I take away Bob, then that leaves me with only 1. So that's why we have to do that, because once you take away one person, that leaves you with something else. Or once you take away one possibility, that means you're left with one less than that. So that's why we have to do factorial. So 4 times 3 times 2 times 1 is 24. Okay, so that's written as 4 exclamation point. All right, so for some examples, we've got, and by the way, 0 factorial is equal to 1, okay? We just have to use that whenever we have a 0 factorial, and you'll see why that's important in a little bit. All right, so say we have 4 factorial. That means you write that as 4 times 3 times 2 times 1, which gives you 24, as we set up here, okay? 3 factorial is 3 times 2 times 1. You always stop at 1. So 3 times 2 times 1 gives me 6. 6 factorial will be 6 times 5 times 4 times 3 times 2 times 1. So 6 factorial, 6 times 5 times 4 times 3 times 2 times 1 gives me 720. Now I'm going to show you a calculator trick on how to get the factorial symbol in your calculator. Okay, so say I want to know what 6 factorial is. I'm going to type in the number 6, then you hit math, then you scroll over to probability, and you'll see the exclamation point at option 4. And so that'll bring up that 6 factorial, which gives you 720. So just to go over that again, 6, hit your math button, then scroll over to probability and go down where your exclamation point is, and that gives you 720. Okay, so say, for example, we want to do 5 factorial over 3 factorial. Okay, so 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. Notice, okay, showing you this mathematically, the 3, 2, and 1 are going to cancel out. So that's just going to leave you with 5 times 4, which is 20. Okay, and if I show you that over here, 5 factorial divided by 3 math factorial gives you 20, okay? Because those numbers cancel out. Once you have a repeating number, it goes away. And another way to write that when you're writing these out, if you go 5 times 4, and then I see that I have a 3 on the bottom, I'm just going to leave that as 3 factorial over 3 factorial, which means they'll cancel out, and I'm left with 5 times 4, which again is 20. Okay, those are just different ways to write that out instead of you having to write this. So say, for example, I gave you 11 factorial over 6 factorial. You're not going to want to write 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and then do the same thing on the bottom and cancel out those individual numbers. Once you get to 6, you can just cross those numbers out. Okay, so say, for example, it says, what if you have permutations with more than one object at a time? So like, for example, a television news director has 8 different stories to present on the evening news. How many different ways can he present those stories? Well, that would be 8 factorial, right? So let's write that out, or let's put that in our calculator, I mean. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. We go math, go over to our probability, which gives me 40,320. So that's 40,000 ways he can do his evening news story. Okay, he can pick and choose which one. But say we have 8 stories, but only 3 of them can be presented. Okay, so how many possible ways can we choose just those 3 stories to be presented? That's what we do. This is called N choose R. Okay, or N permutation R. Okay, where N is the total choices, which in this case is our total choices are 8, so we have 8 to choose from. And then R is the number of choices chosen. Okay, so in this case we have 3. So we have 8 stories. We want to permutate and choose 3. So 8 choose 3. Okay, and the way we set that out in an equation, and you're going to see this equation again on the next page, is you do n factorial over n minus r factorial, and notice that the factorial is outside of the parentheses because that's really important. Okay, so in this case, our n value is 8. That's how many stories we have to choose from. So 8 factorial over 8 minus 3 factorial. Okay, so when we simplify that out, that becomes 8 factorial over 5 factorial, because 8 minus 3 is 5. Okay, and you can type that in the calculator. Another thing you can do is do 8 times 7 times 6 times 5. Notice I've got a 5 factorial on the bottom, so I'm going to leave it as 5 factorial. Those cancel out, and I'm just left with 8 times 7 times 6, which gives me 336 options. Okay, and if you could put it in your calculator, 8 math factorial divided by 5 math factorial gives you 336. Now, if you didn't notice, but I'm going to show you this again, there's another calculator trick here, okay? So we have that NPR. If you go and type in math and go over to probability, look, NPR. All right, so the way you want to type that out is you want to first type the first number in, 8. So 8, go to math, go over to probability, and then hit that NPR button, And then we hit 3 because that's how many choices we want to choose from, which again will give us that 336. So I'm showing you multiple ways in how to create this. You can either, you can type this out into the calculator, 8 factorial divided by 5 factorial. You can write it out like I have and cross those out and see what's left to multiply. Or in your calculator, you can do 8, choose 3, and then you got 336. Okay? So that's all those different possibilities that you can create those 3 different stories that you want to choose out of 8. All right? So then on the next page, again, we've got that formula, n factorial over n minus r factorial. So I'm just going to practice that again. So that would be 5 permutation 3. Okay, if you can see that 5 permutation 3, you would write that in your calculator or write that on your paper, 5 factorial over 5 minus 3, close your parentheses, factorial. Okay, because you have 5 and you're choosing 3. All right, and so in our calculator, or you could continue to simplify, 5 factorial over 2 factorial. Okay, so that becomes 5 times 4 times 3 times 2 factorial over 2 factorial, which becomes 5 times 4 times 3. 5 times 4 is 20, times 3 is 60. Okay, or you can just do the same thing we did here. 5 factorial over 3 factorial. And that gives you 20. Wait, 5 times 4. Oh, I typed in 3 instead of 2. My bad. There we go, 60. Okay. All right. Or you can do 5. Hit your probability or your math button. Go over to probability. Go down to that NPR and select 2. No, we're trying to choose 3, sorry. And we would put 60. Okay? So again, multiple different ways to do that. All right? So then let's try the next one. We got 4 permutation 4, which is 4, choose 4. So we got 4 factorial over 4 minus 4 factorial. And remember, I said on the previous page, 0 factorial is equal to 1. So that becomes, let it get off the countertop. 4 factorial over 0 factorial, which we just said is 1. So that becomes 4 factorial over 1. Okay, and anything divided by 1 is itself. So really we're just focused on this 4 factorial part, which gives us 24. Okay, so that's the first one. So then we have 4, choose 1. This one is kind of like a duh, makes sense, but you don't until you don't really realize it until afterwards. But we have 4 factorial over 4 minus 1 factorial. Okay, so that becomes 4 factorial over 3 factorial. And watch what happens. 4 factorial over 3 factorial, which gives you 4. And the reason why this is kind of duh, it makes sense, is because you have 4 options and you're only choosing 1. So that means you obviously only have 4 different choices to choose from. So that's why that one's kind of a common sense type one. Okay. Then we have 8, choose 5. So we have 8 factorial over 8 minus 5 factorial, which will give you 8 factorial over 3 factorial. And just to show you the other way to do this, you can do 8, math, go to that probability button, hit that NPR, and then hit 5, and you have 6,720 choices. Okay, and then the last one, 12 factorial over 12 minus 7 factorial. Okay, so that becomes 12 factorial over 12 minus 7 is 5 factorial. Okay, and so then you can do 12 math, go over to your factorial, divided by 5 math, go over to factorial, and you get 399,168,0. So 3,991,680. Okay, and again, you can hit 12 math, go to that NPR option, and then hit 5. And oops, what's going on? 12. Oh, because I did 12, choose 5. I meant 7. There we go. Same answer. Okay. So zoom out of there. All right. So for example, say we want a combination lock. We'll open the right choice of 3 numbers from 1 to 30. So this is one of those ones. A combination lock is like that one that you spin around and and there's a bunch of different numbers you can choose from. It says how many different lock combinations are possible assuming no number is repeated. So what that's saying is I can choose any number between 1 and 30, but I only for my lock choice. But I can only use 3 digits. Okay, so I have 30, and I want to choose 3. And none of the numbers can repeat it. So that's why this permutation part is important, because what we did in yesterday's notes, that one lets you repeat the numbers all you want, okay? Because you could do 30 times 30 times 30, and that would be all the different possible options you have. Versus here, I'm going to have 30, and then I'm going to have 29 options, and then I'm going to have 28 options. So there's different options there. And this is why a combination lock is a permutation, because remember, permutation order matters. So if I put in 1, 2, 3 as my lock, and that unlocks it, is 3, 2, 1 going to unlock it too? No. That's why it's a permutation, because you have to think that order matters there. So we're going to do 30 factorial over 30 minus 3 factorial. Okay? So that's 30 factorial over 27 factorial. So 30 factorial, oops. Over 27 factorial, which gives me 24,360. Okay. So out of all, you only get 3 numbers, and so there's 24,000 different options you can choose from. And this is why it's super important that you don't have to do the tree diagram, because you do not want to have to write out 24,000 different options and count all that up. Okay? So then we have a club of 24 members. President, vice president, and secretary, treasurer, and historian are to be selected. How many ways can the offices be fulfilled? And again, this is why permutation is important, because if I have one person that's president and another person's historian, and then I switch those up, that's a different choice, because they have 2 different roles there. So that's why it's a permutation, because the order matters there. So we have 24 people to choose from, and then we want a president, vice president, secretary, treasurer, and historian. So that's 5 different roles there. So that's 24, choose 5. So that's 24 factorial over 24 minus 5 factorial, which will give me 24 factorial over 19 factorial. Or you can just do the 24 math, go over to your probability and hit that NPR and have, we want to choose 5. Wait, 24, choose 5. Oh, wait, what did I do in the calculator? 24 math factorial over 19 math factorial. I think I'm losing it. And then 24 math probability. You don't have to do both of these options when you type these in, but you can use it to help you check, which again, I just typed in wrong. Delete 5. There we go. These 2. Because it's 19 because we took away the 5 down here, but here you have to put in the 5 because that's what we're choosing. So we have 5,100,480 options. Out of those 24 people, we have 5 million options as to who can be any of those. Okay? The last thing we need to talk about with permutations is how to find how many different ways we can order letters, and some of them are going to have repeating letters. So if you look, for example, Miami has 2 repeating I's, and we want to figure out how many different ways can we permutate those letters? How many different ways can we rearrange the letters in Miami? Well, because I is repeated twice, it's going to change up and take away some different options. So what I always do is I write out, okay, I have I that happens twice. All right, and what you do here is the n factorial is how many letters you have total. Okay, so Miami has 1, 2, 3, 4, 5. So 5 factorial over, and then whatever is down here is however many repeating objects you have. So I happens twice, so that's 2 factorial. So that just becomes 5 factorial over 2 factorial. So 5, math, hit our probability, go down to factorial, divided by 2, math, go over to factorial, and that becomes 60. Oh, I forgot m happens twice. Duh, Brittany. Let me try this again. So, let me start over. I and m happens twice. So that means I have to do times 2 factorial again because there's 2 different letters repeating themselves. My bad. So the way you type this in the calculator is you have to put everything that's in the bottom in parentheses. So you have to do 5 factorial divided by parentheses 2 factorial times 2 factorial. There we go. And that gives me 30 different possibilities of rearranging Miami. And the reason why we do that is because this takes out those repeating letters, because that's going to basically give us some of, if we did all of them and we treated I as 2 individual letters and M as 2 individual letters, that's going to give us more options. We need to take out those because then you're going to have repeating options happening. All right, so let's try again with Virginia. So with Virginia, let's see, no repeating V's. I happens 3 times. R, G, N, A. Nope, we're good. And nothing else repeats. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8 factorial. Okay, because that's how many letters we have total. And I happens 3 times, so it's going to be divided by 3 factorial. So 8 factorial. 8 factorial divided by 3 factorial gives me 6,720 options. Okay, that's 6,000 different ways we can rearrange the letters in Virginia. All right, so now let's move on to the word Tallahassee. Okay, so Tallahassee. Let's look at it. T doesn't repeat, but A happens 1, 2, 3 times. So A happens 3 times. L happens twice. H, S happens twice. And E happens twice. So then because, let's see, how many letters do we have total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 11 factorial. And all of these different ones that we have repeating, we have to list all those. So that's 3 factorial times 2 factorial times 2 factorial times 2 factorial. Okay, and all of that is going to be on the bottom. So that means we have to put parentheses around all of that on the bottom. So we do 11 factorial divided by parentheses 3 factorial